Hey guys, let's discuss new problem from binary search, which is called split array largest sum, okay, or the Penter's partition problem. So here, what you need to do, you would have given one array, okay, and k equal to 2. So let's say the array is 10, 20, 30 and 40, okay, and k is equal to 2. So it means k equal to 2 means you have two painters and you have n boards, okay. So first board, second board, third board and fourth board. First board, to paint first board it takes 10 hours time, okay, to paint second board 20, 30 and 40, okay. So you need to what you need to do, you need to split this array or split this board such that you find the you have to your goal is to minimize the time to paint all the board, okay. So what you need to do, first you will, let's take one example, okay. But before that, just discuss what will be the binary search range, okay. So your range will, this is exactly similar problem allocation book, okay, in binary search, which we did just before this video. And here your minimum will be 40, right, because at least you need 40 hours time which will paint all the boards, okay. So 40. And what will be your maximum time to paint all the board is the summation of all the hours, right? It will be 100. So your range will be 40 to 100. And now you will see, okay. So first time you can partition it something like this, that your painter 1 will paint 10 first and second board, and painter 2 will paint third and fourth board, okay. So it will be like 10, 20 and 30, 40. So your maximum is 70, right? With maximum 70, in 70 hours your all boards will get painted, okay. And one more thing, that painter should choose the can paint the consecutive boards only, okay. It's not like that painter 1 is painting 10 and then 30, no, 10, 20 and then 30, 40 for the another painter. Same if painter 1 paint 10 hours of work, if he do 10 hours of work, and painter 2 do 90 hours of work, then 90 is the maximum, right? And again, if the painter 1 do 60 hours work and painter 2 do 40 hours work, then it will be maximum 60 hours will take it, right? So you have found the maximum hours among all these steps, okay, iteration, and then you are finding the minimum one from the resultant. So 70, 90 and 60. What is the minimum one? 60. So 60 will be your answer. And this one will be the binary search steps for this 40 to 100, okay. So initial your low will be 40 and high will be 100, so your mid will be 70, okay. So two partition will be there, this 10, 20 and 30, 40. So yeah, condition true, this is valid. So your high, so now you will search in left side because you need to find the minimum one, right? So your high will become 69. Now your low will be 40, high will be 69. So now you will find your mid will be 54. So you will check for 54, it will be invalid. So your new low will become mid plus 1, so it will be 55. Now you will search from 55 to 69, and similarly when you search like this, your answer will be 60, okay. So in code also we are doing the same thing. Your minimum will be your maximum value of the array, and your high will be summation of the array, okay. And then you just apply your binary search and can divide method. So what it is doing, initially partition equal to 1, because at least you will always have one partition, and then you're iterating that array and you're adding that number into sum until it is less than or equal to your mid value, okay, which is what we are calling here maximum. So from here we are sending mid, and here it is maximum. Once it is crossed your mid value, it means your one partition is completed, right? So what you will do, partition plus plus, okay, and sum equal to number. So again sum will reset for that particular number, and at the end if your partitions is less than or equal to k, then the condition is true, valid, it is valid, otherwise it is invalid, okay. So it will return false. So this is how you will solve this problem. So that's it. Thank you.